Questions 1 through 10 on the 2015 Grade 10 AMC 10A. What is the value of 2 to the power of 0 minus 1 plus 5 to the power of 2 plus 0, all to the negative 1 times 5? 2 to the power of 0 is 1 minus 1 plus 25 plus 0, and then that's to the negative 1 times 5. This is just 25 to the negative 1 times 5. 25 to the negative 1 is 1 over 25 times 5, and that's just 5 over 25, which of course reduces to 1 over 5. So number 1, the answer is C. A box contains a collection of triangular and square tiles. There are 25 tiles in the box containing 84 edges total. How many square tiles are in the box? We have 25 tiles, and some of them are triangles and some of them are squares. And I'll let x be the number of squares, and 25 minus x, therefore, is the number of triangles. Now, if we're counting edges, we know that 4x, 4 edges for the squares, plus 3 times 25 minus x, 3 edges for each of the triangles, times 25 minus x, which is the number of triangles, that equals 84, which is what they told me in the question. There's 84 edges in total. So this is the algebra I have to do. This becomes 4x plus 75 minus 3x is equal to 84. And this becomes x is equal to 84 minus 75, which is 9. And that's it. X is 9, which is what I had labeled the number of squares as. So the answer to this question is D. And made a 3-step staircase using 18 toothpicks as shown in the figure. How many toothpicks does she need to complete a 5-step staircase? So we just continue the same sort of model that they have drawn, but we need to add a few more steps, 2 more in particular. So here's 1, and we're going to just add 1 more. And then we will add up all the toothpicks. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So she needs a total of 40 toothpicks, but she's already used up 18. So she needs an additional 22. She needs to add 22 toothpicks to make this 5-step staircase. And that is, if you can see it, answer choice D for number 3. Pablo, Sofia, and Maya got some candy eggs at a party. Pablo had 3 times as many eggs as Sofia, and Sofia had twice as many eggs as Maya. Pablo decides to give some of his eggs to Sofia and Maya so that all 3 will have the same number of eggs. What fraction of his eggs should Pablo give to Sofia? So Pablo, Sofia, and Maya, and based on the question, if Maya has x, Sofia has 2x, and Pablo has 6x. And then we want all of these to be equal. Well, the total, if you add up 6x plus 2x plus x, that is, of course, 9x. So if we want everything to be equal, we want a scenario where they have 3x, 3x, and 3x like that. In order for this to happen, Pablo would have to give x over to Sofia and 2x over to Maya. So they're asking what fraction of his eggs should Pablo give to Sofia? Well, he should give x out of 6x. So x out of 6x, the x is canceled, which is 1 over 6. So number 4, the answer is B. Mr. Patrick teaches math to 15 students. He was grading tests and found that when he graded everyone's tests except Peyton's, the average grade for the class was 80. After he graded Peyton's test, the class average became 81. What is Peyton's score on the test? Well, 14 students other than Peyton, they scored an average of 80. So that is how much the total is. If I let P represent Peyton's score, once his score is added and you divide by the total number of students, that average is 81. So this is basically the algebra we have to do. This becomes 1120 plus P, and then you will multiply 15 times 81, cross multiply, I guess. And then solving, you will get P equal to 95. So Peyton's score is 95, therefore number 5, the answer is E. The sum of two positive numbers is 5 times their difference. What is the ratio of the larger number to the smaller number? The sum of two numbers, x plus y, is 5 times their difference, x minus y. So let's multiply this out. This becomes 5x minus 5y. And collect like terms, you get 4x is 6y. And then if I put x over y on this side, it becomes 6 over 4. And that's pretty much what they want you to figure out. And obviously, they're going to put that in lowest terms, which is 3 over 2. So number 6, the answer is B. How many terms are in the arithmetic sequence 13, 16, all the way to 73? Well, we have an arithmetic sequence, ... and it goes all the way until 73. Now, in any arithmetic sequence, it's of the form A plus D, A plus 2D, and so on, right? And at the very end, be careful, it's A plus N minus 1D, where N represents the number of terms. So there's N terms, and the very last term is N minus 1D. So let's see what we get here. A plus N minus 1D is equal to 73. Well, A is 13. That's right there. N minus 1, I don't know. And D is obviously 3. The difference between each of these terms is 3. So there we go. Now we can figure this out. So N minus 1 times 3 is going to be 60. Therefore, N minus 1 will be 20, and N will be 21. So number 7, the answer is B. Two years ago, Pete was 3 times as old as his cousin Claire. 2 years before that, Pete was 4 times as old as Claire. In how many years will the ratio of their ages be 2 to 1? P minus 2 is 3 times C minus 2. P minus 4 is 4 times C minus 4. And that's entirely based on what they gave me in the question. So this is what I have to solve. So this one gives me P minus 2 is equal to 3C minus 6. And therefore, P is equal to 3C minus 4. I guess at this point, I substitute this back into any of these. So let's put it into here. So P is 3C minus 4. And then let's multiply this out. 4C minus 16. Collect like terms, you'll get a C here, and this will be 8. Great. So C is 8. I can plug that back into here to get P. P will be 3 times C, which is 24, minus 4. P is 20. So let's figure this out now. P and C. Right now it's 20 and 8. 2 years ago it was 18 and 6, and indeed that's a factor of 3. 2 years prior to that, it was 16 and 4, and that is indeed a factor of 4. So they're saying, when is the ratio going to be 2 to 1? Well, right now it's 20 and 8. So 2 to 1, let's say in 1 year, it'll be 21 and 9. That's not 2 to 1. In 2 years, it'll be 22 and 10. And that's not 2 to 1. 23 and 11, 24 and 12. There you go. That's when it will be a 2 to 1 ratio, and that happens 4 years from now, right? Because it's 20. His age is 20 now. In 4 years, it'll be 24. So the answer to number 8 is B. Two right circular cylinders have the same volume. The radius of the second cylinder is 10% more than the radius of the first. What is the relationship between the heights of the two cylinders? The volume of a cylinder is pi r squared times the height. So the volume of the first cylinder is going to be pi r squared times h1, r1 and h1. The second one is, of course, pi r2 squared times h2. But they told me that the radius of the first one compared to the second one is as follows. r1 is equal to 1.1, or rather r2, based on what the information in the question, is 1.1 r1. So I can substitute that back into here, and they also told me that they have the same volume, so we can equate them. So pi r1 squared h1 is equal to pi r2 squared h2. But r2, well, the pi's cancel, so I can just get rid of that. And then r2 is 1.1 r1 squared, like this. When you square it, it becomes 1.21 r1 squared h2, r1 squared h1 on this side. Well, the r1 squared cancel, so all you're left with is the h1s and the h2s. So h1 is 1.21 times h2. So the first height is 21% greater than the second. So number 9, the answer is D. How many rearrangements of ABCD are there in which no two adjacent and also adjacent letters in the alphabet? For example, no such arrangements could include AB or BA. So what are they saying here? So they're saying that nothing of this kind is allowed. No AB, no BC, no CD. And similarly, the reversals are not allowed, CB or DC. Well, is there anything left? I think so. The only ones that are left, so this is not allowed, these guys. And I guess the only ones that are allowed are if they're not adjacent. So for example, AC, CA, AD, DA, and I think BD and DB. So we can only use these guys to make a 4-digit, I guess, arrangement. And when you fiddle around with this, you'll find that the only way to do it is CA, DB. That's one way. So I use this CA and this DB. And then BD and AC. So I use this BD and this AC. These are the only two. If I try any other combination of these guys, I run into a problem that I get two adjacent. For example, if I chose AD and any of the other ones, I can't because they all have A or D in them. This has A, this has A, this has D, this has D. And there has to be, all 4 letters have to be used. So that's not even going to work. How about if I tried, let's say, AC? If I use AC and then I put, say, BD, those two are allowed, but when you put them together, watch, C and B are adjacent in the alphabet, so they can't be adjacent in our arrangement. So as you can see, when you fiddle around with this, these are the only two that actually work. So number 10, the answer is C.